So we discussed electromotive force, and electric electromotive force is nothing but the potential difference between the two electrodes of an electric cell, right?
Yes,
So
yes.
continuing our discussion, we also discussed that EMF is given by work done per unit charge, right? Now terminal voltage of a cell. What is a terminal voltage of a cell? So when current is drawn from a cell, let's construct a cell. These are the electrodes, okay, and let's say these electrodes are connected with an external resistor, or you can say a circuit, okay. So right now current is flowing through this circuit, right? This is the electrolytic solution. So this one is positive electrode, this one is negative electrode. So current is flowing from positive to negative. So when current is drawn from a cell, when the cell is in a closed circuit, the potential difference between the electrodes, these potential difference between the electrodes of the cell is known as its terminal voltage. Alright? So terminal voltage, we can actually represent this thing this way. This is our external resistance and this is our battery. Okay, so potential difference between the two ends of this cell is basically our terminal voltage. Understood? And
Yes.
more scientifically, we can write its definition that the terminal voltage of a cell is defined as is the work done per unit charge in carrying a positive test charge around the circuit connected across the terminal of the cell of the cell. Alright? So let's say if the W dash is the work done, then work done per unit charge, that is our terminal voltage. Okay. Here the difference is we are carrying this charge through this circuit, okay? And in EMF, we are just it was just the potential difference between the two electrodes when no external circuit is connected, okay? So that was electromotive force EMF, and here if we connect the battery, I mean we connect the circuit with this battery, then we need to carry the electron from through this circuit, right, to the this positive electron. This work done per unit charge is known as terminal voltage. Alright. Now relationship between EMF and terminal voltage of a cell. What is the relationship between relation between terminal voltage and EMF of a battery? What do you think? What will be the relationship? So let's construct our battery again. This is our battery. These are the electrodes, and it is connected to some external circuit. Okay. This is positive electrode and this is negative electrode. And this is our electrolytic solution. Alright, so by the law of conservation of energy, we can write down the total work done as work done to take this charge from this through this circuit, right? And the small work done. This small work done is to carry the charge from one electrode to another electrode through this electrolytic solution. Yes or no?
Yes.
Okay. And if we divide this work done with charge, then we know that this W by Q is nothing but our EMF, right? This W dash by Q is our potential terminal voltage, and this is small w by Q is our small v, okay? Yes or no? Therefore, we can write E is equal to capital V plus small v, okay? It can be plus V or minus V, alright? So thus when current is drawn from a cell, its terminal voltage is less than its EMF, okay? Why? Because there is some voltage drop inside this cell, yes or no? That is our small v, okay? So that we
Okay.
need to either add or subtract from this terminal voltage. Then we can get this EMF. So this is the relationship between terminal voltage and EMF. Generally, we get it as E minus IR is equal to capital V. This is our terminal voltage, okay? Or E plus IR, okay? You will learn these things in your higher standard properly, okay? Why we write IR, okay? Alright?
Yes.
Now, internal resistance of a cell. So this small r was the internal resistance. That let's just discuss it, okay? Internal resistance of a cell. Alright, now internal resistance of a cell. So when a cell is in a closed circuit, when a cell is in a closed circuit, the current flows inside the cell through its electrolyte. Yes or no? Maybe draw this cell here, and this is the electrolyte. So current flows through this electrolyte. Yes or no?
Yes.
Due to the flow of ions, okay, both cations and anions. So while outside the cell through the external circuit, so due to the flow of free electrons, okay, the the outside current is due to the flow of electrons, while the current inside this solution is due to the flow of ions, right? Cations and anions. So it flows from anode to cathode, okay? Inside the cell, electric current flows from anode to cathode inside the cell through the electrolyte so as to maintain a continuous flow. Okay, so the resistance offered by the electrolyte inside this cell is called internal resistance of a cell. Okay, the resistance offered by the electrolyte inside the cell to the flow of current is known as what? Internal resistance. We represent this internal resistance with small r. Okay, remember this is the resistance of the electrolyte solution. Okay, resistance offered by the electrolytic solution. Okay,
Okay.
current flows in this direction, let's say. So this solution offers some resistance. That some resistance is nothing but our internal resistance. So it is the internal resistance of a cell due to which its voltage drop on a drawing current from it. It is denoted by symbol small r, okay, and its unit is ohm as usual. So if we want to write this, so there will be some potential difference, right, due to this resistance, yes or no? Due to this resistance, okay, this small r resistance, and that can be written as current multiplied by resistance according to Ohm's law. Okay, this is the small v. Okay, that is the voltage drop due to this internal resistance. Are you getting my point?
Yes.
So for circuit analysis, the internal resistance small r of a cell is considered to be connected in series with the cell. Okay, this way for circuit analysis. All right. Now
Okay.
relationship between the EMF, terminal voltage, and internal resistance. That is this equation. Okay. So if you want to write the relation between EMF, internal resistance, and terminal resistance. So let's say this is the terminal voltage. This is our internal resistance. This is EMF. This is external resistance. So what's the relationship between terminal voltage, EMF, and internal resistance? So we know that total resistance here will become what? Hmm?
Good afternoon, everyone. I am Anisha and against my
Is given
Sir.
by capital R plus small r. So according to Ohm's law, here this is our EMF instead of voltage. This is I, and instead of R, this is total resistance. Okay, here we can write R plus small r. So from here we can write total current as E upon capital R plus small r. Very important formula. Okay, and from here the EMF becomes E is equal to I multiplied by capital R plus small r. Okay, and the terminal voltage is given by this terminal voltage. It is given by V is equal to I multiplied by only capital R, that is the external resistance, because this potential is across this capital resistance. Okay, alright, and the potential drop across this IR is our small potential. Okay, yes or no? So
Okay.
EMF, total EMF can be written as the summation of this potential and this potential, capital V plus small v. Capital V is capital IR and small v is I multiplied by small r. So it would be I multiplied by R plus small r. Okay. So it is either V plus V or V minus V. Okay. Yes or no?
Okay.
Alright. So this was the relationship between terminal voltage, EMF, and internal resistance. Now, what are the factors affecting the internal resistance of a cell? So I'm not writing it down, but I'm just mentioning them, okay? Factors affecting the internal resistance of a cell. So first one is surface area of electrodes. Second one is the distance between the electrodes. Third one is the nature and concentration of the electrolyte. Fourth one is the temperature of electrolyte. Alright.